Hi, thank you for joining me today. My name is Shai Petel and I'd like to talk to you about building .NET client tools for SharePoint Online. I'd like to focus on SharePoint Online when it comes to authentication or other limitations like app throttling that we have there, but everything we say today, all the tools we're talking about today can definitely work on your on-premise environment. A little bit of background information about myself. I'm one of the founders of Quiscom Corporation. I'm the research and development manager of the company. And what we do is we're a SharePoint vendor and we have lots of add-ons for SharePoint, full trust solutions and apps in the App Store. That gives me a unique point of view for everything that I build and I produce because I have no control over the topology of the farm of my clients, where they're installing or how they're using our products. So my contact information is right here below. Please feel free to contact me regarding any questions you might have about this session or our company as a whole. I was also awarded the Microsoft MVP Award 5 times, still an MVP, and used to be an MCT certified trainer, used to give a lot of SharePoint development courses. So let's get started. I'm going to divide today's talk into three. We're going to give a broad overview of what apps are. What do I mean when I say an app? Why is it different than a SharePoint solution? We're going to deep dive into the differences between the different kind of apps like web apps, client tools, SharePoint hosted app, or provider hosted app. And then we're going to see how to build apps. I'm going to give you two examples of client tools that we chose to implement as client tools and not as full trust solutions or SharePoint apps. When we're saying SharePoint apps, we're basically talking about a way to extend SharePoint to provide more functionality on your SharePoint server without actually installing or running any code on the SharePoint itself. When we talk about full trust solution, it's very tightly coupled with SharePoint. It's installed on SharePoint, executes on SharePoint, and when it crashes, it might affect your SharePoint server. When we're talking about SharePoint apps, we're talking about a way to actually extend or expose some new functionality into your SharePoint site without running anything or affecting your farm or your SharePoint server itself. Well, apps don't run any code on your SharePoint server. They either run client-side code on the browser on the client, or they execute server-side code on your own server, the provider-hosted apps, or a client tool that runs its own code on the client. They use client-side APIs to communicate with SharePoint. So you see how SharePoint apps are really loosely coupled with SharePoint and not really a part of the SharePoint server itself. Although they're very loosely coupled, they do provide new functionality using their user interface or can introduce new user experience into your SharePoint site. They can do that using the browser, using scripts, HTML or CSS files, using server-side code if you run it on your own server, or using the client you can run on a PC, an app on your mobile or tablet device. Now, everybody says they don't require SharePoint development skills at all. I'd like to say they don't require much SharePoint development skills because it's really depending on what you're trying to achieve using your app. If your app trying to create content in SharePoint, read it, expose it in some other way, then obviously you need to have some basic understanding of the way that SharePoint content is built and stored. So how does your app communicate with SharePoint and consume or create content in your SharePoint site? Well, basically apps need to use some sort of client-side API to do the job. So there's the REST API, which basically is the fastest and slimmest one of them all. You basically just create a request to get information or create information in SharePoint, get a really fast JSON response in return, or XML if you'd like. There's the JavaScript API, which is basically a bunch of objects on the JavaScript itself, client-side, and you can use them to collect a bunch of requests and send them asynchronously to the server and get a response. Now, the client-side API does not have its own login framework, so it's only available using SharePoint hosted apps. And we'll talk about authentication later and mention that. And there's the .NET API. There are actually a few APIs for .NET, for Silverlight, for mobile. The .NET API, very similar to the JavaScript API, consists of objects that you can work with. And they translate into calls to services or to REST requests or whatever needs to be done on the server. All these APIs share some restrictions like app throttling or app level permissions, and we're going to talk about these restrictions a little later, and we're going to see which one has which restriction and how to overcome them if you'd like or if you need to in your app. It's important to understand that all three APIs go through the same tunnels to communicate with the SharePoint server itself. So basically, whatever you do, boils down to that API translating your code into requests that are sent to the underscore API service or VTIB client SVC service and gets the response from there. Now let's talk a little bit about the context that your app is running under. So we mentioned that apps are very loosely coupled and they're not running on your SharePoint site, they're not installed on your SharePoint site. So how do you know which site are you supposed to work at, right? You can have the same app servicing hundreds, thousands of sites, servicing 1,000 users. How do you know the context that you're running under? So basically SharePoint provides you the context using a query string. It's called SPHost URL. And this is something you have to consume and you have to get if you're planning to use any of the client-side APIs. The only API that doesn't require you to have the SPHost URL is the REST API. When you're using the REST API from within a SharePoint hosted app, then you can make requests using the app web URL and get content from your host web or any other site on your site collection. Any other API or any other scenario requires you to know the URL of the site you're working at, and there's no API to give you that information. The only way to consume it is using that query string. So when you're in a SharePoint hosted app, if you're using REST, there is really not much you need to do. But if you're using the client-side object model, here's a little nice example of how to use the object model to get the context web that you're running under and not the app web that your app is installed to. Now, when you're using provider-hosted app, your code actually runs on your own server. So you're going to get that query string, SPHost URL, and here's the code that you need to run in order to get the context associated with the right SharePoint site and the right access token or authentication based on the user that's right now using your app. Now I want to mention in SharePoint hosted app that you don't have to worry about authentication because this is taken care of for you using the single sign-on. And we'll cover that a little bit more when we talk about app authentication. Now, when you're using your own client tool, when you're building client apps for SharePoint, which are not provider hosted and not SharePoint hosted, so in client tools, it's up to the developers to decide how to provide the site URL or the context, including the authentication to SharePoint. So in client apps, all options are open for you, and you'll be required to either provide it hard-coded in a config file or send it as a parameter to your app so the app would know which site it needs to run on. And there's also the app authentication that we need to consider, and we're going to talk about it next. The first thing you need to do when you want to use any of the SharePoint APIs is authenticate against SharePoint. So for SharePoint hosted apps, that's taken care of for you because your app is running inside a browser and the browser already has the user login information to it. So all your requests basically are already authenticated against SharePoint. If you use the client-side API, you don't have to worry about anything. If you use the REST API for some requests, you might be required to send with your request the form digest token, which is also available for you on the page itself. For provider-hosted app, you're going to use OAuth for authentication against your SharePoint site. So basically your app, when you add your app to your site, you trust it, it gets a sort of a token, and there's really clear API to get that token, and every request you make into the SharePoint API, even using REST or client-side object model, you're going to have to send that token along with your request in order to get authenticated. With client-side apps, the situation is a bit different. You have a few more options to consider. The first option is to use default credentials. Here's a little simple code sample for how to use your default credentials. This would work if your client is currently running and connected to a domain or has saved network credentials for that specific source, and then your app can take advantage of that. So that's probably not the case or not your best choice for 365 in most scenarios. The next option is to create network credentials. For that, you would need your user to provide a username and password to your app. But this again creates a generic network credentials, which most likely will not work with SharePoint Online. But SharePoint Online has their own unique login classes which you can take advantage of. It's using a secure string to provide the password and then creating an SP Online credentials object. And it works similarly as any regular network credentials, which you would use if you're using your app on-premise. Last but not least, there's the OAuth approach, which is what the SharePoint hosted app and provider hosted app are using. So for OAuth, you have a token helper class with source code that Microsoft provides, and it allows you to get access token and then create a context with that access token. Now you'll notice with OAuth, there's a huge difference when you're connecting to SharePoint and running your code against your SharePoint. When you're running under OAuth, then your app has to be trusted and it gains its own trust level. So every request you're running is basically tested against the current user permission. What kind of permission does the user have? Can he edit an item or delete an item? But on top of that, it's tested against your app trust level. So if you're trying to delete an item, your app needs to have delete permissions as well as your user. With the other options of authentication, you don't have that limit of the app trust level, and you're only running under the user permission level. Now that we know a little more about the different kind of apps that we have for SharePoint, let's talk about how you choose between the different kinds of apps. I came up with a set of questions I ask myself every time I'm trying to implement a new solution for SharePoint that allows me to choose the best kind of app, client-hosted, SharePoint-hosted, provider-hosted, that would fit best for that situation. One of the first things I ask myself when I'm building an app is who is going to use that app? Is that app going to be used by a specific group of people? Does it require any rich user experience that cannot be provided using the browser? Or does the app need to run very lengthy, large operations on my SharePoint, like a timer job, or let's say a find and replace tool and something like that, that would probably not be ideal to run inside a browser? On the other hand, if the app really belongs to the content it's working on, let's say it's exposing a new view of the content of the site or providing you with a new way to input information into SharePoint and needs to be used by any user that's visiting that site, you might want to go with a web app. You might also want to ask yourself what will feel more natural for the people who are actually using the app, for your target audience. If it's an IT crowd, they're used to using tools, they're used to using desktop tools that run and perform operations on the server. For users who are using the SharePoint side, they're already inside the browser working on SharePoint, so it doesn't really make sense to take them outside in order to submit some sort of information to SharePoint. On the other hand, they might be using their phone or their tablet, so you might want to build an app for that platform for them. So it really depends on where you want the app to be available and what's your target audience and what they expect to have. Let me give you a few examples. Let's say you're building a backup tool, backup and restore, or you want to do some kind of governance or reporting tools on SharePoint. Those things might make sense to build as an app, since they should work on any site and only administrators or maybe IT professionals should use those tools. On the other hand, if you're collecting all the tasks from the user and you want to show them in one consolidated to-do list, for example, or if you have a calendar that's supposed to show me all the events that I'm invited to from various team sites, that would make sense to build as a SharePoint app and have that as an app part appearing on my site. The biggest difference between the apps for the user is basically the experience he's getting from each type of app. So with client apps, you can give the best experience for the user using his specific device. You can integrate with any kind of input that device provides, like a touch screen or a pen. And you can also integrate with camera, printers, use client-side Office API to create and produce documents and richer documents than what you could do on the server, or even integrate with GPS on the device if it's available, or other sensors on the device if they're available. The downside of client apps is that they target a specific device. So they're built to run on a PC or on a tablet or an iPhone or Android or Windows Phone, but there's no real cross-platform solution. It's true that Microsoft are talking about cross-platform apps for Windows 10 that would work on the phone or any other version of Windows, and there's the Cordova project for building mobile applications, native applications for iPhone, Windows Phone, Android, and BlackBerry, but none of them are currently real cross-platform and allow you to take advantage of everything that the specific client has to offer. Well, when you're building web apps, you don't have any easier task on your hand. You have to rely on the browser that the current user is using, and you have to talk about not just cross-platform, but browser compatibility. We all seen our sites broken by every major browser upgrade from IE 6, 7, 8, 9, now we have 11. We have to support the new Edge browser coming out. Chrome and Firefox are very popular, but if you're using iOS, you might use Safari. And from my experience, building a site that would actually behave and look the same in all browsers is not an easy task. On top of that, you have to use JavaScript, CSS, and HTML to provide your user interface and user experience, and as such is a little bit limited versus client apps. It's true that you can get much richer controls and a better experience if you use objects like Flash, Java, or Silverlight, but then you won't be cross-platform and your site, your app would not work on all devices. Now, I mentioned with client apps you can bypass the app trust level permission check, but there are a few limits that are true for all kinds of apps. The first one is the client-side object model 3-level throttling mechanism. So right now, when you're using client-side object model, your code is throttled at the list level, at the user level, and also at the app level. I'll show you some code examples on how to make your requests as small as possible in order to avoid that throttling limit of your apps. But basically it means that you have to keep the state of your app when you're running against a lot of data in SharePoint in your app itself. It has to know what happened and what the data I collected so far, and then go ahead and continue the task or operations that I'd like to perform. Now, for that reason, client apps behave much better when you're doing large operations on SharePoint. When you're using web apps, your browser is more vulnerable to crashing, closing, or by mistake when you swipe left or click the escape button or backspace button, then your browser browses back for you and you lose everything you just typed in on your page, which can be a bit frustrating for the user. Here's a nice little code example that allows you to avoid the list throttling and the user and app throttling. When you're trying to query a list with over 5,000 items, your query would probably fail, and you can break them into getting 500 rows at a time, and then you have to make that request again and again until you get all the items in that list. In this example, when I want to query a list with over 5,000 items, I have to keep my list item collection position as the state between each request. One more important aspect is how to push updates of your apps to your users. If you're building web apps, either for a mobile tablet or just a browser, I strongly encourage you to store most of the files on your own server. We use apps.quizcom.com. You can build whatever FTP site you'd like to host those files. The major benefit of that is you can start publishing updates to your FTP server, and all your users will get the update pushed down to them automatically. But again, some changes require a change on the app itself, the app structure itself, and would require you to submit a new version of the app to the store. When we're using client tools, it's really different between the platform you're targeting. When we're targeting desktop PCs, then we can use the click once, and I'll show you examples on how you use click once to easily deploy and update your clients. You can actually mark mandatory upgrades or an optional upgrade. And with click once, you can also block your app from running on the desktop without visiting your site first. So you can say that the only way to run this app would be to visit your site and launching it from there, versus creating a link to the desktop at the user, and you can launch the app without ever visiting your site after installation. Click once updates will still get pushed to him. Once he launches the app, you can decide if you want to check for update before the app launches or after, once a week, and the user can actually skip non-mandatory updates if he doesn't want to update. Let's talk about how do you build apps for SharePoint. Now, when you used to build SharePoint Full Trust solutions, you had to run on the SharePoint server itself. With apps, the story is completely different. Your development machine doesn't need to have SharePoint running on it. You can build apps using any Windows 7 or above, Windows Client, or Windows Server 2008 R2 and up. All you need to is to install Visual Studio 2012 or up and install the SharePoint client-side component SDK. You don't even have to have a SharePoint server because you can get a free development site from Microsoft that you can build and test your app against. I'd like to talk a bit more about the Click Once option when you're building client tools for desktop PCs. Configuring Click Once on your Visual Studio project is relatively simple. All you got to do is take your project, go to the project properties, and configure the publish location, the FTP where you want to drop your package. This is where you handle versions. You specify the version you want to progress, and if this is a required upgrade or not. You tell your Click Once how to handle updates. In the option, you can specify if you allow URL parameters to be passed to your application, or if you would like to create a desktop shortcut. Now, like I mentioned, if you want to make your application available offline as well, you might want to create a desktop shortcut for it. You also need to set the security for our application. A full trust application will require more privileges from the user to run it versus a partial trust application. And I really encourage you to sign your application using a code sign-in certificate. So a strong key is nice to have, but I also encourage you to sign it digitally so the user installing it won't be prompted and warned about unsigned packages running on his computer. The way you publish it is that the Click Once solution creates basically a package for you. It's a folder with files that you have to either drop to an FTP site or a web server, or even you can wrap it inside a WSP and host it in your SharePoint site. If you are interested in signing your solution, I just want to mention one more thing. Please remember you also have to sign the files after they've been compiled in the Click Once package, and for that you can edit the project file and add the digital signature to every file in your package. If you choose to pass parameters to your application, such as the website that you're running at, then remember that it only works on IE. Now, the parameters only get sent to your app the first time it launches. If you allow to launch it from the desktop, the parameters will not be kept, so you have to save them yourself using isolated storage. To fix that behavior on other browsers, there's a really nice trick you can do. You can actually create a dedicated setup file for that set of parameters and redirect the user to that specific setup file. So if I want to launch my app and have it point to http://mysrv as the SharePoint host site, I can actually use those two lines of code to create an executable file that points directly to that site. Now, if I point users to that executable file, it would work on all browsers. And later on, remember, I need to read those parameters from inside my app. The first time it launches, I should probably check if it's network deployed and then get the parameters from the activation URI. I can get the query string and parse the query string from there. But remember that when the user launches the app from the desktop, you have to store those parameters for him and reload them the next time the application starts. And later, when it's time to update your application, remember you can always use the Click Once properties for handling updates, when to check for updates, and if the current version you're publishing is mandatory or optional. I'd like to show you a couple of sample Click Once applications that we built for SharePoint Online. The first one is SharePoint Find and Replace. This is a very basic tool that allows you to find information on your SharePoint site, and I want to show you how we handle the login and getting the client context. So first of all, to install a Click Once application, it's basically just a link on your site. You click on that link, and then you click on the install button. You can actually launch it directly from that link as well. Now, this application did not get any information from the site and doesn't know where it's running at or doesn't have any user context. So let's just create some test here so I can show you how we handled it with this application. Basically, in this application, it's running on multiple sites at the same time, and we want to run under the specific user permission. So we're going to ask the user to provide a username and password and type in the URL of all the sites he would like to work at. The other application I'd like to show you is our web installer. Our web installer is actually packaged as a WSP and installed on SharePoint just for the purpose of serving the installer link. But now you can see in this application, I can actually send a parameter to the application when I'm launching it. For example, I'm going to launch it to install the Calendar Plus web part. When I click the Click Once installer, you see that update window again. And then, as soon as I get to the second screen, you'll notice that Calendar Plus was already selected for me. Now, in this case, this application doesn't require any login, so we didn't have to go through any authentication since this site is available for anonymous users. So when you do have to collect information from the user, like the context or the login information, I strongly urge you to save it in isolated storage. So the next time you launch your application, it will be available for you, and you don't have to prompt the user each and every time. So here's a nice code example on how to save information in isolated storage, and you can see I'm encrypting the username, encrypting the password. It's also stored in a storage that's only available for your app and for the current user, not available for any other app, not available and not exposed for any other user using the same machine. And here's the lines of code of how to retrieve that information later on when your app launches, and then you can decrypt that information and use it using your application. So that's all for today. If there's any questions, I'll be happy to answer you either via Twitter, or you can just use the chat right now. Or send me an email. Here's my contact information just in case you need it again. Thank you very much. And my name is Shai Petel. And here's a few additional links you might be interested in. This presentation will be available on my blog, and you can actually click those links and not just look at them.